Good night, Dr. Reyes. My name is Cristina Raya. I'm a student of the Master in Marketing, and I'm gonna explain the task the extra task regarding to the confidence interval for the difference between two means. It is possible to find a confidence interval for two population samples when we know the standard deviation of each one. For example, this is very useful when we are trying to compare the difference in income for a population of men versus women. Another example is when we are trying to analyze the difference on consumption between populations on low versus high income, for example, differences in age of Republicans versus Democrats, the daily output of two machines, or the response of two patients receiving different drugs, different treatments. So there are a lot of uses of this measurement. To calculate the confidence intervals for two populations, we need to estimate the difference between the two population means. By taking two population means mu1 versus mu2, by taking the difference between the two sample means x bar 1, x bar 2, and adding or subtracting a margin of error. The algorithm to build the confidence interval for two means with normal distribution and known standard deviation, it's x bar 1 minus x bar 2 plus minus zeta value multiplied by the root square of the standard deviation of the standard deviation squared of the first sample divided by n, which is the size of the first population, that is added as a sum to the standard deviation squared of the second sample divided by the n size of the second population. So to calculate the set value in Excel, we use the function norm is inverse with the alpha value that we want to get divided by 2, and this is gonna it's gonna give us the value to the right. So we're having this example: build a confidence interval at 94% for the real difference between the duration of light bulbs of two different brands. The sample of 40 light bulbs from the first brand is taken randomly, showing a mean duration of 418 hours with a standard deviation of 26 hours, and this 26 hours, and the second brand having a sample of 50 light bulbs with a mean duration of 402 hours with a standard deviation of 22 hours. So as these are considered samples with a normal distribution, the difference between the means of the samples will be the estimator for the population. So we are having the data here: x bar 418, x bar 2 402. The size of the first sample is 40, the second sample is 50, the standard deviation of the first sample is 26, and the standard deviation of the second sample is 22. So having that, we calculate the estimate value, which will be in this case x bar minus x bar 1 minus x bar 2, which give us 16. Then we define alpha, which for this exercise is for 94%. It's 0.06, and we are going to use this in this formula, the alpha divided by 2, which is 0.003, which gives us 0.95 to the right. So we calculate that with the function inv norm or norm inverse at 0.97, for a mean and standard deviation of 1. So it gives us a set value of 1.88. So we calculate then the margin of error according to the formula, multiplying C times the square of what we just commented, the square standard deviation of the first sample divided by the sample size and added to the squared standard deviation of the second sample divided by the sample size. So that will give us the margin of error of 9.70, and we just add or rest that margin of error from our estimate, which gives us on the lowest interval 6.30 and on the upper interval 25.70. Of course, there are other ways to calculate the intervals when we have unknown standard deviations, and also when we have standard deviations that are the same. They are known but are the same for both of the samples. But this will be a matter of another exercise. Thank you so much.